Alrighty, we have the Spaghettios mini ABCs of 1, 2, 3s. It has all the letters, numbers, and meatballs, so we'll just take the numbers and meatballs out afterwards, but let's go ahead and get all these in here. And we can get more of them out. I put water in the can and I dumped it out, so now all we gotta do is rinse and then we can start counting. Bon appetit, am I right? Give me you. Alright, anyway, so now that we have all of these like this, I need to go ahead and separate all of the letters from the numbers, so let's do that real quick. And well, this is going to take a while trying to sort through all of these Spaghettios, so we'll do a classic time lapse. Alrighty, I am done sorting them. Here are all of the numbers, if anyone was wondering, and I already ate all the meatballs, so no more meatballs. Anyway, yeah, that's what we got. I think the main problem here is that we have 3 A's, which is bad. We have a lot of Z's, and a lot of V's, and a lot of Y's, and none of those really help us that much. So we'll go ahead and see what happens. And with the power of editing, let me take you to my desktop. Alright, now you're here through the power of editing magic. You just saw me count the Spaghettios, and now it is time to actually apply the letters gained from that can in a program. So, let's go over the premise of the program first. So the whole point is to take the letters and the amount of letters that we got from that Spaghettios can and calculate how many cans and how many letters it takes to create a book. Now, the book I have picked is Schindler's List. It is a very good book, and it is also a movie, and it is a very good book and movie. If you've never seen it, I highly recommend it. But anyway, so this program will access this text file, which contains the entire book, and then based on the amount of letters per can, and then based on the amount of cans, it'll tell you how many cans you need, how many letters you need, how many leftover cans and letters there are. That is kind of the entire point of the program. Oh, one thing. It also tells you how many letters were used to generate it. So it'll tell you how many A's, B's, C's, D's, E's, F, G's, H's, I's, whatever. You get the point. It only calculates letters, by the way. So special characters like exclamation point, hashtag, at, colon, semicolon, whatever, are not counted because I just don't count them because they're not letters. So we're not counting those. Although we could, we're not. So now let's go ahead and go through the actual program itself. Firstly, anything that is green are comments, meaning that this is not actually ran when the program is run. It is just here so that somebody watching, such as yourself, or the programmer or programmers, can have a better time understanding what these things are. Because anything in blue is, or light blue, I should say, not this dark blue. Anything that is light blue is human named. So instead of naming this can values, which represents like the letters, if I were to name it this, it's a little confusing figuring out what it is, and that's not obviously what somebody would do. However, you can see where it would get confusing if somebody uses different like naming conventions than you do. So comments are a very helpful tool for understanding code better. So let's go ahead and start at the top. These are libraries, and they are needed to write code, period. Input and output, this allows us to actually print stuff. So when I run the program, all of this stuff is an input output. It requires the cout to actually be put out to the console itself. So cout total letters, total letters, total letters as an integer, which is just the amount of letters, which is right here. Currently at 0, that changes through the code down here. But anyway, you get the point. You need this to actually be able to get information and output information to the console. Fstream, this is required for file manipulation, so essentially accessing files, opening files, closing files, reading files, using the files for different things, writing onto files, creating new files on your computer. Anything that deals with files you need Fstream for. And the reason I actually just restarted the recording is you actually don't need string. I just reran the program and I figured something out. The more you know. We're in this together, guys. You know, we figure out stuff together. Anyway, string is not actually needed, so I'm not going to go over it. Next, we have namespace standard. This just allows for the code to look less messy, essentially, and also save time. Because if this wasn't a thing, I would have to type std : before pretty much everything, which the code will still work even if it's not there because I'm using namespace standard, so it will just assume that it's there without me actually typing it. It just saves a lot of time and a lot of heartache and a lot of annoyance because this will typically create a problem where if you're not using it and you're wondering why your code's wrong, it's not that the actual code's wrong, you just forgot to put standard : So using this is a very good tool. Now, I do have comments for every single pretty much individual line. I'm going to go over this more overall-y because going into every single line, explaining every single line is tedious, and it's not really necessary for actually understanding what the program does. So I'm just going to kind of go over it overall. So I'll kind of go over this as like one whole thing, and then this is one whole thing, and yeah. So this right here will check if the file was successfully opened. So if file is opened, do this. And all this code does is it will make an array of counts for each letter starting at 0. So the reason 26 is here is because I didn't really want to do this. But essentially, this is what actually keeps track of how many letters there are. So this is how many letters are per can. This keeps track of how many letters there are in the text file itself. Then what we do is we assign a variable char c, and the c is not actually representing the letter c, it is just representing a character. So you can almost think of it like as a ghost character, because what it's going to do is, let me reopen that text file right quick. What it's going to actually act as is it's going to act as a placeholder. So it'll have no value, then it'll read s, and it'll say, okay, I am now S, and then it will increment the counter for S to 1, and then it'll go C, and then it'll go H, and then it'll go through the entire document line by line, adding a value to the correct letter. And this right here just makes it a bit easier because if we look at the code, all of these are in uppercase, and that's what you want it to be in. That's what the that's kind of what the project says, is that you want them to all be one value. So what this will do is if the letter being read is lowercase, it converts it to capital, and then it will run this, which is if the letter is capital, increment the proper value. And if the letter is already capital, then this doesn't run because the if statement is not true, so then this just runs. Like I already explained this, I'm not going to explain it again. Total letters, this just keeps track of like, it's kind of self-explanatory, the total letters. So when we have, it's saying 656,137, this is just the total amount of letters. And we can figure that out by just adding all of the separate letter values for like A, B, C, D, E, F, G, all the way through Z together. Then we have cans needed. This variable just will hold how many cans you need. It's kind of self-explanatory. Max sets, this just keeps track, or well, not really this keeps track, but this expands to the number right there. I'm not going to bother saying it, but that is actually the highest value an integer can be. And the only reason I actually have it is because when dealing with files this big with 650,000 characters, there's a decent chance that if I use a different file, it would actually go over. So this is just foolproof planning for different file types. So if I decide to use a bigger file next time, it'll save me. Leftover sets, this keeps how many leftover sets there are. This for loop will count the total number of letters. Like I said, it'll go through this letter count list, and then it'll make the total letters equal to letter counts at index I. So for example, if I equals 0, it's counting for A, and if it's at 1, it's counting for B. And that might be a little confusing, but in code, 0 essentially is 1, right? So if it's 0, it's A. If it's 1, it's B. It'll go through the list all the way to 26, and then it'll add the respective value for each letter to it. Then down here, this just calculates the number of sets needed for a letter. So if we go back to the code here, And when I say sets, the reason I'm using sets here and not cans is because this is like a set, almost like this is a set of numbers. But if you really want to, you can just think of set as cans. But besides that, yeah, this will just calculate how many cans are needed for the respective letters. So in this instance, we need 7,344 cans for letter K. That's what that does. This will increment the sets needed if there are leftover letters. So for X I believe has actually the least. Oh no, it's actually Q. Q has the least amount of cans needed. However, we still actually need 124,949 cans to generate it, which means that subtract that from a 125,949, subtract 541, and then every point after that, you are just getting leftover cans in terms of Q and leftover letters in terms of Q. So that is what this kind of does. It kind of calculates how many leftover letters there are for every single letter. I just gave a specific example for Q. This holds the minimum sets needed and updates it. Same thing for this. This just updates the total sets needed. Then down here, this calculates the leftover sets by making leftover sets equal to cans needed, and then minusing the max amount of sets that we had. So in this instance, it would be 125,949, and then leftover cans are right here. And then, yep, does that. And then this prints out the actual results. So whenever you see C out, this is something that's actually going to the console. So this is actually what you see, but this is all of the background work that is required to make you properly see this and have it work. So we can actually go through it line by line, and you'll see exactly what's happening. And I hate when it does this. I have no idea why it does this. You can run it again and it'll be fine. I don't know why it does that. But so look, total letters, and then it sees out the number. All of these blue things are just number values. That's what they are. And then we go to the next one, cans needed to generate the text file, cans needed, and then we go yada, yada, yada. This is a for loop. This just makes it a little bit simpler when seeing out all of this, because it's really annoying to type see out, it takes blah, 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 cans Spaghettios to type for letter A, and then going over and over and over and over. And it also makes your code really long and kind of hard to read. So this for loop essentially just does that for me. It takes letter of cans, which we can get from up here at this integer, letter counts. Letter counts is up here, my bad. Yeah, so it takes letter counts here, and then cans of Spaghettios, and then char a plus I. That's a little hard to explain. It's kind of hard to read, but essentially that is just what it allows it to actually print out the respective letter, is as easy as I can put it. And then this else here, so this is also kind of hard to explain. So this if statement, or all of these if statements essentially, if the file is not accessible ever, it will just say this here. So that's what that for. And then return 0. This is just something that you want to always have, because it will make sure that your code is actually running. So if you're having a problem in your code and return 0 is not happening, then you can figure out that your code isn't accessing this, and it allows you to kind of pinpoint where a problem is. But yeah, that's the program. Explanation of the project. Oh, one final thing. The limiting factor. That's something else I have to talk about real quick. So it requires 125,949 cans to generate the text file. Well, I'm sorry for stepping over my words. The limiting factor is whatever takes the most amount of cans to actually make when it's disproportionately required. So if there were a bunch of A's and you actually had a lot of A's and it still took a lot of cans, that's technically a limiting factor, but it's still okay. But the main limiting factor in this one is E. There are a couple others, like these are ones that are really high, but E is insanely high because we only have 3 E's and it's a very, very, very popular letter. So we had to use 82,552 cans of Spaghettios to get enough letters for E, which means that we had to waste a ton of other letters, because remember, whenever you get a can, it gets every other letter, even if it's used or not. So we had to use a ton of E's. And yeah, that's pretty much everything. So thanks for watching the video. Appreciate it, and I hope you have a good rest of your day. Goodbye.